Hey guys, I hope you all are doing good. In this lecture, we will try to understand what are upper bounds, lower bounds, supremum and infimum, right? So basically, these are kind of weird definitions. So if you don't understand what I'm trying to say, don't worry. We will cover these concepts in detail, right? Before I start, it is very important that you have covered some concepts before you're watching this video, right? So before you watch this video, you should understand what is a Hasse diagram, right? How do we draw a Hasse diagram, and how do you you should understand how to basically represent it and interpret it, right? Second thing is you should understand what is a partial order relation and what is a poset, right? So I've covered all these concepts in detail in some of the previous lectures. So if you don't understand them, then I would suggest it. And even if you have like a good understanding or a decent understanding about them, then this lecture should be pretty easy to understand, right? It is all about some definitions, but without an understanding about those previous concepts, it's going to be tough to understand, right? So let's start with what is upper bound, what are upper bounds and lower bounds, and then we will understand what is supremum and infimum, right? So let P be a poset and S be a subset of this poset, right? So I'll just still try to give you a basic explanation. So what is a poset once again? So for example, let's say I have this set A, right? I say 1, 2, 3, and I have this P, right? So let's say I have this relation R, right? Now, if this relation is a partially ordered relation, then I can say that it forms a poset, right? Poset is basically some kind of a AR representation. Here, A is the set A and R is this relation such that this relation is a partially ordered relation, right? Okay, what is a partially ordered relation? It is basically a relation which is reflexive, anti-symmetric, and transitive, right? So I hope you understand what is a partially ordered relation. Now let's try to understand what is an upper bound and lower bound. So let P be a poset and S be a subset of this poset. An upper bound of S is an element. I'll try to read the definitions first and then I'll explain what they mean, right? They might seem kind of confusing, but they're pretty easy to understand. So an upper bound of S is an element U, which is an element of P, such that for all the values S in the set, S is less than equal to U. I'll try to explain this with a small example, right? So first, let's say I have this A is equal to 1, 2, 3, 6, right? So let's say I have this set and I define a relation on it, right? Let's say I define the relation that A is related to B if A divides B, right? A R B if A divides B. This is the divide sign, right? So I'll just divides B. So for an example, what does this mean? So since I know one divides two, right? One divides two into two different parts, right? We know that. So, or I can say two can be divided by one, three can be divided by one, six can be divided by one, right? Similarly, six can be divided by two, six can be divided by three as well. So I can say one is related to two, two is related to six, three is related to six, but 6 is not related to 3. Why? Because I cannot divide 3 by 6, right? So I hope you understand the relation we are talking about. Now, I'm going to draw the Hasse diagram for it. So once again, if you don't understand what is a Hasse diagram, I would highly suggest that you watch my previous lecture in which I've explained how Hasse diagrams work, right? So let's say I have this Hasse diagram, right? It's basically going to be 1, right? 2, 3, 6. Okay, let's move on to the definition once again, right? An upper bound of S. So S is a subset of this poset. So let's say I take a subset of this set A, right? These are all the elements that I have in my poset, right? I'm going to take this subset 2, 3. So usually what happens is you have a subset of a poset, right? And you are trying to find the upper bound and the lower bound, supremum and infimum for it, right? So for example, you might get a question, okay, you have this Hasse diagram or you have this relation, right? And this is the subset, find the upper bound, lower bound for it, or maybe the supremum and infimum for it, right? So in this case, let's say I consider this subset 2, 3. Upper bound of S is an element U such that for all the values s, right? In this case, s is this set 2, 3, right? So we are saying for all the values, s is less than equal to this upper bound. So let's try to understand what we mean, right? What I'm saying is we need to find some kind of an element, right, such that it is all these values are less than that element, right? And what do we mean by less in this case, right? We're not talking about numbers in this case. We're not talking about numerically less than value. So don't confuse that over here. We are talking about, so if I say a is related to b, or if I say, this basically means in this case a is less than equal to b, right? So I know this is kind of a tricky definition. I know in general, numerically, has a different meaning, but in this entire section of lectures that we are covering, a related to b basically means a is less than equal to b, right? So in Hasse diagram, you would represent it as a, I should say a b in this case. If b had another element c, then I would say b is related to c, or b is less than equal to c, and a is also less than equal to c, right? So just a quick definition once again. I've covered all these concepts in the previous lectures, but still, because since this lecture requires like a lot of prerequisites, I'm still trying to give you an idea about what they mean, right? So moving on, right? I have this Hasse diagram. I've been given this subset, and I'm trying to find the upper bound and the lower bound for it, right? According to the definition, I need to find a value such that all these two values, these values 2 and 3, are less than it. So I hope you understand what does less mean. What I'm trying to say is I need to find a value such that 2 is related to x, 3 is also related to x, right? So my question is to find this value x in this case, right? So I would suggest you can pause this video and try to understand what is x in this case, right? Okay, so I hope you have figured out what is x, or what is the upper bound. In this case, it is simply going to be this value 6. Let's try to understand why once again. I have this subset. I'm trying to find a value which is greater than it. So I see 2 is related to 6 given in the Hasse diagram. 3 is also related to 6 as well. So for this subset, upper bound is going to be the value 6. Okay. Now let's try to understand what is the lower bound for this case, right? A lower bound of S is an element L such that for all the values, this value L is less than equal to S. So now what I'm trying to do is I'm trying to find a value which is less than 2 and less than 3 as well. So in this case, so this is for the upper, right? For the lower, I would have something like this, right? So if you kind of get confused, then try to form this kind of a figure, right? I think it will help a lot. So in this case, what I'm trying to do is there's some value x that I'm trying to find such that x is related to 2, x is related to 3 as well, and I'm trying to find what is this value x, right? So once again, you can pause this video and try to figure out, and the answer is simply going to be this value 1. Why? Because think about it, right? 1 is related to 2, 1 is related to 3 as well, right? I hope you understand the difference between what is the upper bound and lower bound, right? From an Hasse diagram, I think it should be just simply clear what is the upper bound and lower bound, but sometimes you might not be given the Hasse diagram. So this is the way that you try to figure out what is going to be the upper bound and what is going to be the lower bound. But my personal suggestion would be, if you have this kind of a question, right, trying to figure out maximum, minimum, upper bounds, lower bounds, etc., right? My suggestion would be that you draw the Hasse diagram, right? And then try to figure out using that Hasse diagram, right? Because it makes things a lot more clear. Okay, so I hope you were able to understand what is the upper bound and what is the lower bound in this case, right? This is the way that we find it. Now I'll give another example for you guys to solve, right? And then we will move on to understand what are supremum and what is infimum. Okay, let's try to understand the supremum and infimum in this case, right? So I've arranged the definitions. I'm sorry for that, but I hope you can just pause this video, go back, and keep that screenshot in your mind, right? Or just keep the definitions in your mind for upper bounds and lower bounds. right? So let's try to understand what is the supremum and what is the infimum. The supremum, or the least upper bound, is the smallest upper bound of S. It is unique. The infimum, or the greatest lower bound, is the biggest lower bound of S, right? So let's try to understand what this basically means, right? For an example, let's say I'm considering this subset, right? So this is a Hasse diagram. I'm not giving a relation. I'm not given any relation, and not even a set of elements. But let's say you have these elements from A to G, and this is the Hasse diagram related to it, right? Let's try to understand what is going to be the upper bound and lower bound first, and then we will try to understand the supremum and infimum. So let's say I have this example. I consider the subset D comma E. Remember, the subset could be anything, right? So maybe the subset could be D, B. Maybe the subset could be C, D, E, right? So there's no limit to it in a case, right? So let's say for this example, let's try to consider C, D, E in this case. Okay. So now there can be multiple upper bounds, right? There can be multiple upper bounds that we can find. So let's try to find the upper bounds for C, D, E. What is an upper bound? Once again, all the elements which are greater than all, which are basically greater than all the elements in this set, right? So let's try to figure out. Okay, I see C, I see F is greater than C, F is greater than D, and F is greater than E as well. And also, G is also greater than all these three elements. So if I talk about my upper bound, then it is basically going to be this set F comma G, right? Now let's talk about what are going to be the lower bounds in this case. So I'm just going to circle the elements that I'm considering, right? Now lower bound is going to be all the elements which are lower than it, right? Or so in this case, if you look at it, B and A are the lower bounds. Okay, so just like I said, if you have the Hasse diagram with you, it becomes a lot more easier to solve the problem. But even if you don't have the Hasse diagram, again, the relation to find is, in order to find the upper bound, I'm trying to find a value such that C is related to this value X, D is related to this value X, and E is also related to this value X. And when I'm trying to find the lower bound, I'm talking about X is related to C, X is related to D, and X is related to E as well. So this is for the lower bound, right? This is the lower bound, and this is the upper bound case, in case you have not been given the Hasse diagram, right? But with the Hasse diagram, it's pretty easy to understand. So what are going to be the lower bounds in this case? It's basically going to be the set D comma I, because both of them are less than this, right? So now let's try to understand what is the supremum, or the least upper bound, or the infimum, which is the greatest lower bound. So the point is very simple, right? We are talking about, when we talk about the least upper bound, we talk about the first upper bound that we have above these elements, right? Like just the one upper bound above it. That's what we are talking about. So if you look at this example, right, I have two upper bounds. I have F and I have G as well. But if I talk about the least upper bound, right, least upper bound, which is like the first upper bound, I should say, is going to be F in this case. So supremum in this case is going to be F, right, because it is the least upper bound. It's the first one that we are connecting to, right? So, and the infimum is basically going to be the greatest lower bound. What is the greatest lower bound in this case? It's just one step below it, right? It's just one step below all these set of elements. So in this case, the infimum is going to be B over here. Right? So once again, just a quick overview and a summary of all these different points, right? When we talk about, let's say you're supposed to figure out upper bounds, lower bounds, supremum and infimum, right? You probably would have been given a relation. So if you have been given a relation, my advice would be that you try to convert it into a Hasse diagram first. Once you have a Hasse diagram, make sure you don't make any mistakes in the Hasse diagram, right? And even if you don't want to, then I've given away. So convert it into a Hasse diagram, then what is the upper bound? Right? Upper bound is going to be all those values that lie above that set, right? They're connected to all those values in that set, right? So for example, F is connected to all three of them, You need to understand that, right? If that was not the case, then f would not be the upper bound for these three elements. Remember, all three of them should be related to that element in order for it to be the upper bound, right? And it could be the case that you don't have an upper bound or you don't have a lower bound, right? That's also possible, so that's totally fine. Now, so upper bound is going to be the element that lie above it, right? They are connected to those elements, and lower bound is going to be the set of elements which lie below it and they are connected to it. So in this case, upper bound is f and g, all these three are connected to them, and lower bound is b and a because they are lower than them and they are connected to it. Okay. What is supremum and what is infimum? When you talk about supremum, if you look at the Hasse diagram, it is basically the upper bounds, but the first upper bound in that case, right? So in this case, this is the subset I was considering. The first upper bound, or I should say the least upper bound, right, is going to be f because it's the first one that we encounter, and then we encounter g. But the the greatest lower bound is simply going to be the one step below the set of elements that I'm considering, right? Now, if consider a very simple example in this case, you might not get this simple example, but I'll still give you guys questions to solve, right? And I think those questions will make things a lot more clear, and I'll give the answers in the description as well, right? So now moving on, let's try to take a look at the final concept, which is the lattices. Okay, let's try to understand what is a lattice, right? So lattice is basically a poset which has, for every pair of elements, it has a least upper bound and a greatest lower bound, right? So the basic point is that I need to consider all the pair of elements that I can form, and for each one there should be a least upper bound and a greatest lower bound, right? And if that's the case, we can basically say it's a lattice, right? So let's take a look at some of the examples in this case, right? Let's say I pick the pair B, comma, C. So let's take a look at what is going to be the least upper bound and what is going to be the greatest lower bound. So for BC, the least upper bound is going to be D in this case. If you move the arrows, it kind of goes like this. This is the first point that they meet. So D is going to be the least upper bound. What are going to be all the upper bounds in this case? D and F are going to be both the upper bounds for this, right? Okay. Second, what is going to be the greatest lower bound? A is going to be the greatest lower bound, right? Because that's where they meet on the downward side. Okay. Let's take a look at another example, right? Instead of BC, let's pick a more tricky example in this case. Let's say I pick B and E in this case, right? So in this case, I'm considering BE. So for B, if you take a look at it, the first time that they meet, right, which is the least upper bound, is going to be F in this case, right? That's where they meet. So F is going to be the least upper bound. We found the least upper bound, right? What is going to be the greatest lower bound? Greatest lower bound for BE is going to be A in this case, right? So we found both the least upper bound and the greatest lower bound as well. Okay, let's take a look at another final example. Let's say if I'm considering DE, right? In this case, let's say I'm considering DE. Similarly, for DE, I have F is the least upper bound, C is the greatest lower bound, right? So if you take a look at this example, if you consider all the possible pairs that you can find, for all of them, you will find a least upper bound and a greatest lower bound, and hence you can say that this is basically a lattice, right? So that was it for this lecture, and I think this is going to be the final lecture for this series. A lot of the further complicated concepts I'll be covering in another series for discrete structures too, right? So I hope you were able to understand all these concepts, and I hope you had a good time. And thank you so much for all the support. Okay, now I'll be giving a bunch of questions for you guys to solve, and then that would be the end of this lecture, right? Okay, so I've given two questions on the board. The first one is literally the same one that I solved in the video, right? The reason I've given the same question is I think if you just try to solve this question yourself, it will give you a general idea about how these definitions work, right? For the second one, you're supposed to draw a Hasse diagram for the power set of xy under the relation subset, right? So A is related to B if A is a subset of B, right? Okay. So first question is it a lattice? So you're supposed to figure that out. And the second one is find the meet and join of xy. So in this case, join is basically the least upper bound, right? This is the another way of saying these definitions. Join basically means the least upper bound, and meet basically means the greatest lower bound, right? So I hope you would be able to solve these questions. I will put the answers in the description or in the comments, and I'll see you guys in the next lecture.